Hello, my name is Eleanor and I'm the Education Manager at Benjamin Franklin House. Welcome to this week's live science class. This week we're going to be looking at Ben Franklin's invention of the long arm and also thinking about how he would have used his knowledge of forces to help him come up with this invention. But first of all, some housekeeping. So as always, we are really looking forward to your participation today, whether that be asking or answering questions or giving us comments or feedback. And if you're watching live, there are two ways that you can do this. So the first way is to use your raise hand button. And you can get this up if you tap or click, tap the screen or click your mouse. And then you should get a banner of some different icons, and one of them should have an icon of a hand. And if you press that, then my friend Caitlin, who also works at Benjamin Franklin House, will be able to unmute your microphone and then you can ask your question. I'll do my best to answer it. The second way you can ask a question or give us some feedback if you're watching live is by using the Q&A button. So once again, if you tap the screen or click your mouse, you get that banner coming up, and then one of the icons should be two speech bubbles, and if you press on that, then you can type your question and Caitlin will read it out and I'll do my best to answer it as well. Now, we are recording today's session. And so if you're watching this on YouTube, then you can ask questions by leaving them in the comments. And anyone can always get in touch with us via email as well by sending that email to education@benjaminfranklinhouse.org. So on to the topic of today's lesson, this invention which Ben Franklin called the long arm. Now, on the left of your screen, you can see an illustration of what this would have looked like. Unfortunately, we don't have Ben Franklin's original long arm. We don't have that artifact, but this illustration and some others, another one I'm going to show you, were done based on his description of what it would have looked like. So this picture actually came from one of the lessons that's on the Franklin 300 website. So Franklin 300 was an exhibition that toured around America and came to Europe, and that was in 2006 because that was the year that we celebrated what would have been Franklin's 300th birthday, also the year that we opened Benjamin Franklin House. And on that website they have got so many amazing resources, so I really recommend that you check that out. You can go there by going to www.benfranklin300.org. So this is from one of their lessons on that website. So this is the long arm. And so as you can see from the quotation, so the writing that's on the right hand of the screen, Ben Franklin really invented this mainly to help him reach books from high shelves. And we've spoken before in these classes about how Ben Franklin was always trying to improve things and looking at the world around him and looking for jobs to do, things he could improve. Like when he came up with the bifocals, when he started to need help seeing things close up as well as far away. So he was always trying to fix things and improve things. And he was also endlessly curious. So this is one of the reasons that he was inventing things from when he was a young boy all the way up until the end of his life. And he wrote about this long arm invention in 1786. So this is when he would have been 80 years old. So it was one of his last inventions. And at this point, when he was thinking about the long arm, Ben Franklin had already left England, where he'd been living at 36 Craven Street, the house we now call Benjamin Franklin House, and we hope to be able to visit when we reopen as well. He'd left England, he'd spent some time in France, and now he was back in America, in Philadelphia, living with his family, and that's where he came up with this idea for the long arm. So let's find out a bit more about what inspired him to create this invention. Now, we have another illustration of Ben Franklin's long arm on the left. This one is from a really fantastic picture book called Now and Then, The Modern Inventions of Benjamin Franklin, which was written and illustrated by Jean Beretta. And I really recommend that as well. It's a fantastic book. So you can see Ben Franklin using his long arm there to reach one of the books on his tall shelves. Now you can see from the picture that Ben Franklin had a really big personal library at his home, and we've also spoken in some of the previous classes about the fact that Ben Franklin was a real lover of books. I wonder if anyone remembers some of the things that he did, which shows us how passionate he was about reading and about books and learning. Does anyone remember some of his jobs that linked to books?
We have a raised hand from Irene.
Hi, Irene.
Hi. He was a printer, which meant that he probably quite liked books and words and printed stuff.
Absolutely, thank you. You're quite right. That was his first proper job. He was a printer. So like you say, he had to print books, also newspapers. And something else he did, which he's maybe less known for, but was also really important, is he founded the first conscription library in America. And that still exists today as the Library Company of Philadelphia. And so he founded that because he wanted to make sure that lots of people could share books and share knowledge and have access to the different books. So it really was very important to him. So we can understand part of the reason why he had the idea of the long arm. He was always trying to read books, and even ones that might be high up on the shelves. And we also spoke about how he invented this towards the end of his life when he was an older man. And at the bottom of the screen, you can see his explanation of some of the features of being an older person and how that meant that he needed a long arm. So he said that if he'd had to climb up and down ladders, he might have found himself feeling dizzy, and also his joints were getting stiffer in his old age. So even the climbing up and down was difficult for that reason too. Now, later on in the description of the long arm, which that quote comes from, he explains what it's made out of. So Ben Franklin's long arm was made out of wood and some string or rope, like you can see in the illustration. And he talks about the top part of the long arm. He says it's a bit like a thumb and forefinger. So that's what it was inspiring as well, a bit like some pincers on a crab or something. So that's how he made his long arm. And then on the right of the screen, we've got a picture of a kind of modern day version, which you've probably maybe seen before. We might call them a grabber or a reacher. And normally today, these would be made of plastic and a slightly different design to Franklin's, but the same idea. Although we usually use them to pick up things maybe from the floor, maybe litter, for example, rather than these heavy books that Franklin was trying to get from high up. So like I said at the beginning, Ben Franklin would have needed to use his knowledge of forces to help him invent the long arm. I wonder, it's a bit of a tricky question, but I wonder if anyone could try and explain what forces are.
We have a raised hand from Zach and Louis.
Hi, Zach and Louis.
Is it like wind or something? Is that a force?
So wind can enact a force. You're on the right track, definitely. So that wind can have a force. The way we really describe forces is as pushes and pulls. So I'm going to show you a diagram to help explain. Hopefully you can see those diagrams on the board. So all forces are either pushes or pulls. And so Ben Franklin's long arm would have been using a pulling force because he would pull on the string, which would close the kind of pincer at the end to help him bring his book down. Now, forces, we can't really see them, but we can see the effect they're having. So the different effects they can have on objects is that they can make them speed up, make them move more quickly, can make them change direction, and it can also make them change shape. So, for example, if I take a rubber band and I exert a pulling force on it, I'm making it change its shape. So all those examples I've given, and like in the diagrams, we've got the pushing and pulling of the box, which would move it either backwards or forwards. Those are all examples of contact forces. So something has to touch something else for it to happen. But there are some types of force which we call non-contact force. So I wonder if anyone can think of forces that they don't need to be touching something else for them to have that effect on objects. Another quite tricky question.
We have raised hands from Jessica.
Hi, Jessica.
Does wind move without touching?
So that's a difficult one because wind it does actually touch things, although we can't always see that that's happening. But good try. I saw maybe there was a comment in the comments as well.
Yeah, Iram says wind as well.
Wind as well. Okay, I'm gonna show you the non-contact forces now, some more diagrams. So the three that I was thinking of was gravity, magnetism, and static electricity. So let's go through how those are non-contact forces. So, so gravity, that's super important. That is the force that's kind of holding us all together, and also it's pulling things down to the earth so we don't fly off into the sky. So we've got gravity. It's also what holds all of the planets in orbit around the sun, and also our moon orbiting around the earth as well. So that's gravity, it's a pulling force. And then we've got magnetism. Now, magnets, you've probably seen, can attract things that aren't touching them. But as well as being a pulling force, it can be a pushing force. So I mentioned how magnets can attract things like metal or other magnets, but they can also enact a pushing force. Does anyone think they can explain how magnets would push things away and why that happens?
Zach and Louis have raised their hands again.
Is it? Well, can you hear me?
Yes. Hi.
Okay. Is it when the magnetic forces of the North and South Pole, of both poles of the same side collide, and both of them do not, and the fields collide and push away?
Yeah, that's so well explained. Thank you. Exactly. So when you have two North Poles or two South Poles, just like Louis explained, they push each other away, they repel each other. So magnets can create a pulling and a pushing force. And then the third example was the force created by static electricity. So this is that type of electricity that's created through friction. For example, you can create it by rubbing a balloon against your hair. And once again, with static electricity, sometimes it creates a pulling force and sometimes it creates a pushing force. Does anyone think they can explain the different ways that could happen?
We have raised hands from Jessica.
Hi, Jessica.
Is it force or something like that?
Yeah, so looking at the picture, the example of the pulling, so when you've rubbed the balloon against your hair and you pull the balloon away, what happens to your hair normally?
It gets stuck to the balloon. It gets stuck to the balloon.
Yeah, exactly. Thank you. Exactly. So it gets pulled towards the balloon. So that's the pulling force. And then if you actually rub two balloons, and it does that because the balloon has become negatively charged and your hair is positively charged. So they're different, they're opposites, and they attract, they get pulled towards each other. But if you rub two balloons, they both become negatively charged, and then because they're like charges, they're going to repel each other and push each other apart. And if you do want to learn a bit more about static electricity, you can always go back and watch our very first class in this series, which was all about Ben Franklin and his lightning rod, which is just on our education page of our website. There's a link there. So those are non-contact forces. Thank you so much for your participation. Now, there is a way that we can measure forces, and I wonder if anyone's heard of this. I'll give you a clue. The unit of measure and also the device that we use to measure forces are named after another famous scientist who we remember mainly because he discovered gravity. I wonder if anyone knows his name.
Jakob and Yasin have said in the chat, Newton.
Exactly, thank you. So Sir Isaac Newton, a British scientist, mathematician, physicist, he made that discovery a bit before Ben Franklin was born, and Ben Franklin really admired Newton. Unfortunately, they never met, but because of these really important discoveries that Newton made and the theory he came up with around gravity, we've named the unit of measure for force Newton, and the symbol for that is a capital N. And here's a portrait of him. So there's Sir Isaac Newton on the left, and that portrait is by Sir Godfrey Kneller. And on the right is the device we use to measure forces. So it's called a Newton meter or force meter. And hopefully you can see the way it works is inside there's a spring, and at the bottom there's a hook. And so the force that's pulling down on the hook then pulls down the string, and we get the spring, sorry, and we get a reading. So the greater the force, the more the spring gets extended, and the greater the reading, so the more newtons. Okay, so something else which Ben Franklin would have had to consider when he was creating his long arm connected to forces was thinking about friction. So I've got a diagram here to help us, but I wonder if anyone has heard that word before, thinks they might be able to explain a bit about what friction is, how it works.
We have a raised hand from Irene.
Hi, Irene.
Hi. Friction is like when you push something one way, friction repels the other way. So if you're cycling up a hill, the faster you go, the more friction your wheels make, and that's part of the reason why it's harder to go up the hill. Or if you've seen people on BMXs going around vertical sides of places, it's because it's the friction that's keeping them up.
Great, thank you so much. You're quite right. So you feel a frictional force when two objects are moving against each other. And just like Irene explained, so the friction, and hopefully you can see from this diagram, the friction is acting in the opposite way to the movement, okay? And sometimes friction can be quite unhelpful. So Irene was explaining about how it gets quite difficult when you're trying to cycle. And if we go back to thinking about pushing the box, for example, the friction between the box and the floor, we're making that harder work for you. But the nature of the surface will affect the friction. So if the surface is really smooth and slippery, like on ice, for example, there's less friction, so it's easier. But if it's quite a rough surface like concrete, then that's going to create quite a lot of friction, so it's going to be quite difficult to push that box. But sometimes friction can help us. So on the right of the screen, that picture is of the soles of some trainers. So one of the main ways that friction helps us is making sure we don't slip when our shoes are walking on the ground. And that's why with active shoes, like trainers, they're often designed to make sure they have good grip on the bottom. And this is something that Ben would have had to think about with his long arm, especially thinking about what he referred to as the thumb and forefinger at the end. He would have wanted to make sure that had a good grip so that the books wouldn't slip out of that when he tried to pick them up. And that's something that I'm going to be asking you to think about as well, because now I'm going to show you how you can create your own modern version of Ben's long arm at home. And but I'm going to show you the basic design, and then I'm going to set you a challenge, see if you can improve it and give it more grip. Okay, so there are quite a lot of steps to making the long arm. So it might be a good idea to maybe note down the things you need and the steps, and then have a go at making it after the video. Right after the class, I'm also going to put up a little clip on our website showing you how to make it again if it goes a bit too fast and you want to watch again. And this whole class will be up by tomorrow as well. So let's start with what you're going to need for your long arm. Actually, firstly, I'll show you what it will look like at the end. So this is the long arm, and let's see how we put it together. So you're going to need a big piece of cardboard, maybe from an empty box that you can recycle. Then you're also going to need a rubber band, ideally a sort of thinner one, some string, again quite thin would be good. 4 split pins, so that's these little pins we've used before that you can open up at the bottom. Then you'll also need either a ruler or a tape measure, some scissors, and some tape. Oh, and a sharp pencil. Okay, so that's all your materials. The very first thing you'll need to do is we're going to measure and cut out some strips of cardboard. Now, I did this before the class, but when you do it, you'll need to measure it out on your big piece of cardboard. So I'll show you what the measurements need to be. So firstly, you're going to want to make some long strips. This is going to be for the handle of your long arm. So you're going to want these to be about 40 centimeters long and 4 centimeters wide. Now, to make sure that the handle is quite strong and doesn't get too bent, when you're cutting your cardboard, you want to cut along the line of the cardboard. So if you look at it very closely, I'm not sure if you'll be able to see on the screen, there should be some faint lines going along this way. So you want to cut it in the same direction. And ideally, if you could have about 4 pieces like this, and then we're going to tape them together to make the handle, to make it nice and strong. So once again, that was 40 centimeters long, roughly, and then 4 centimeters wide. So 4 strips like that, if you've got enough cardboard. The next one, we've got some medium-sized strips. So we're going to need 3 strips, which are 26 centimeters long and still 4 centimeters wide. So 3 strips like that, which are 26 centimeters long and 3 centimeters wide. And then we're going to need 2 small strips. So these ones are going to be 13 centimeters long and still 4 centimeters wide. So 13 centimeters long and 4 centimeters wide. Okay. So once you've cut all those pieces, and I know you won't have a chance to do that as I'm going along now, but hopefully you could do that after the video. So you take those long pieces, so remember I made 4, and I'm going to tape them together, so get them in line, and then I'm going to tape them together in a few places to make sure they stick together. So one at the top, one at the bottom, and then I'm going to put 2 in the middle as well. Okay, so that's going to be my, my sort of handle for the long arm, and I'll come back to it in a moment. But now I'm going to go to my medium-sized strips. So remember, we need 3 of those. So these ones were 26 centimeters long and 4 wide. And we're going to make some holes in some of them. So the first one, we're going to fold it in half, like this. And we're actually going to attach it to one of the ends of the handle. So we're going to fold it over. Now you want to leave a little bit of cardboard at the end, because we're going to poke a hole through here. And if we try and poke a hole through all of the pieces of cardboard, that's going to be tricky. So we want to leave a little bit at the end where it's just the 2 folded sides that we're poking through. So we want it to be at least about 1 centimeter away from there. So I'm going to use tape now to attach the top. Okay, so now that's attached, I'm going to take my sharp pencil, and about 1 centimeter, so you might want to use your ruler or your tape measure, you're going to poke a hole in the middle at the bottom. Okay, and I'm going to make sure it's gone through to the other side as well. Okay, so we've got our hole in the middle at the bottom. So now we're going to make some more holes on the other 2 medium-sized strips. So on these, you're going to want to do a hole about 1 centimeter away from the bottom, and then another hole in the middle. So maybe using your ruler or tape measure to do that. So the middle about 13 centimeters in. So I'm going to do that on both of the strips. I'm carefully poking them with my pencil. In the middle as well. Okay, and then I've got a hole at the end and a hole at in the middle of both those medium-sized strips. And then I'm going to take the small strips, and we're going to want a hole at each end, again about 1 centimeter in. You want to be careful, try not to bend the strips as you're poking the holes, so that will keep them nice and strong. Okay, so we're at a point now where we can start putting everything together. So I'm going to take my handle and my two medium-sized strips. So the medium-sized strips we're going to put in a cross, and we're going to take one of those split pins, and we're going to attach them together by putting it through the holes in the middle, so it becomes like a cross. And then we're going to attach it to that hole at the end of the handle. And when I attach it, I want to make sure that the other holes on these medium-sized strips, I want to make sure they're facing the handle rather than facing away. Okay, so when it's through the other side, you'll see the split pins coming through. And I'm going to fold it over like that. And you may want to put a bit of tape down on there too, just to make sure it doesn't come apart. So that's our first pin. Okay, and now we're going to take those small strips, and we're going to attach them together with a split pin so it makes a kind of big V shape. Okay, and once again, I'm folding it at the back and potentially putting some tape down there to make sure it doesn't come apart. Okay, now we can see our long arm coming together. So the next thing we need to do is use the last two split pins to attach these small strips to the ends of the medium-sized ones. So we're going to put them in these holes. Okay, so we can see it coming together now, and that it's starting to act like a long arm. But we want to have that string element, a bit like Ben Franklin did. And the way we're going to do that is we're going to take our rubber band, and this bit is a little bit fiddly. We're going to need to thread it underneath the heads of these split pins here. So it's going to be going between these two split pins. Okay, so we've got the band stretched between those two split pins, and then I'm going to tie my string underneath this bottom one, so the one that's pointing towards the handle, and then I'll be able to pull it open and close. Okay, and then we have our modern version of Ben Franklin's long arm. Now, I did say there was a challenge at the end of the demo. So I've made this long arm, and I said this is kind of the basic version. So once you've made this, you'll probably find that actually it's not that good at picking up lots of different things. So I've got a little ball of tin foil here, which I'm going to try and pick up. Okay, so I can pick that up with a little bit of difficulty, but I think we could improve the design to make it easier to pick things up. So that's my challenge to you. Once you've made this, I wonder if you could experiment with some different ways of potentially adding extra bits of cardboard on here to make the grabber part a bit smaller, or maybe thinking about another material you could add on here to create some more grip, some more friction that would help you grab hold of more of a range of items. So thank you so much for joining us today. I wonder if anyone has any questions before we end the class.
Yeah, we have a raised hand from Jessica.
Hi, Jessica.
What if you didn't have what if you didn't have any cardboard? Would there still be a way to make it?
Without cardboard, you could maybe make it if you had like a cereal box, or so it's not quite as thick, the cardboard, but you could maybe still make it with that kind of card, so from a cereal box. Hopefully, I know that other than the split pins, lots of this can come from your recycling. And as I said, I will put the little how-to video up in just a moment on the website, so that you can watch again if you need to see that again. And also next week we've got a really exciting class, because we've actually got a guest. We've got a friend from another museum, the Newington Green Meeting House, and she's going to be doing an experiment that's all about states of matter using a fizzy drink. So all the details of that are going to be up on our website from tomorrow. So I do hope you'll be able to join us for that. And we're continuing our classes up until mid-July. So we'll be putting the details of those up on the website too. And we hope you'll be able to join for them. But thanks so much for joining today, and hope to see you next week at the same time. Goodbye.